Continue with the Navier-Stokes, uh, the derivation of the Navier-Stokes equation. We have seen up till now how the left hand side had evolved to this and the right hand side had evolved to this. Now we will be using this term. We will be working on this term, right? To simplify this term, we will be considering four assumptions. I'll tell the assumptions one by one. When the fluid at rest, the stress is hydrostatic and the pressure is thermodynamic. From this assumption, we can write that sigma uh, sigma ij is equal to minus p plus sorry delta ij. I'll tell you what delta ij is, plus tau ij, right? Delta ij is known as Kroneker's delta. Which means that delta ij is equal to 1 when I is equals to j, delta ij is equals to 0 when I is not equals to j. This is the Kroneker's delta, right? This we can write from the first assumption. Now assumption number 2. Stress is proportional linearly proportional to the deformation rate of deformation. Deformation rate tensor, right? So sigma ij is proportional to, this is the deformation rate tensor. We can write it as, because tau ij, sigma ij depends on tau ij, so we can write this as alpha depends on the equality. The proportionality constant will be something called alpha. This is a tensor of second rank, of rank 2. This is another tensor of rank 2. If you want to relate this, you need a tensor of rank 4. So IJKL, this will be the rank 4 proportionality constant that will relate the shear stress tensor and the deformation rate tensor, right? Now what is this deformation rate tensor? Let us consider a fluid element A, B, C, D, right? This has moved in space, have both rotated, sheared, translational movement has been there. This have moved to A dashed, B dashed, C dashed, D dashed. The angle which AD dash makes with the vertical is delta beta. This is delta alpha. This is the direction of rotation of alpha. This is beta, right? This point, this point of the fluid moves with a velocity of v. This point of the fluid moves with a velocity of u. This distance is delta x. This is delta y. This is this dx, and this is delta y, right? Excuse me. Now if we see from this figure, we can say that tan, if we just see this, if we drop a perpendicular b double dash, and if we just see this triangle, right, this a b dash b double dash, this is d alpha, tan of is equals to b dash b double dash by a b double dash, right? Now what is b double dash? It is the distance which this fluid particle has moved up, right? What is the velocity of this fluid particle at v double dash in the y direction, right? It will be some v. The v will have a gradient of dv dx in the x direction. So this will be v plus dv dx, because if this is having a velocity of v, this portion will have a velocity of dv by dx to delta x, right? We'll have to, this is the velocity of this point minus v into delta t. Let's say this has moved for a time period of delta t. So this will be b dashed b. And AB from this figure we know is delta x. So we have b dashed b double dashed by AB double dashed is equals to dv by dx delta x dt. The stat since alpha is very small, sorry, d alpha is very small, tan d alpha can be written as d alpha, and we can bring this dt term down, so d alpha dot is equals to dv by dx, right? Because ab is delta x, so this term and a delta x over here will get cancelled. Similarly, we can see that beta dot equals to du by dy. Now we will be defining three terms. Rate of rotation tensor, rate of shear tensor, deformation rate tensor. This is in the clockwise direction. Because this was the direction of alpha, this was the direction of beta, so this is half beta dot minus alpha dot, which is equals to half du by dy minus dv by dx, right? This is equals to half beta dot, this comes from the definitions, half du dy plus dv dx. Deformation rate tensor EKL is the summation of this, we can see is the symmetric part, antisymmetric part, this is the antisymmetric part, this one, right? So this will be a summation of symmetric plus antisymmetric, half du dy minus dv dx plus half du dy plus dv dx. This will be equals to or in a more general term, EKL shall be equals to duk by dxl. This is the deformation rate tensor. See you in the next video.